Hello guys, and welcome back to our series on solved problems on Newton's laws. And this time we are going to discuss problem number 4 on your worksheet. So let me just quickly read it to you. 3 blocks are stacked on top of one another as in the figure. The top block has a mass of 4.6 kilograms. The middle one has a mass of 1.2 kilograms. And the bottom one has a mass of 3.7 kilograms. Identify and calculate any normal forces between the objects. Now, what we need to understand in this situation is that in order to have a clear picture, you do need to organize your knowledge. You should start by having names for the objects. So let's call the red block on top block A or mass A, the middle one block B, and the bottom one block C. If such is the case, then you can start by telling yourself that at least you know the masses of each. The mass of block A is 4.6 kilograms. The mass of block B is 1.2 kilograms. And the mass of block C is 3.7 kilograms. Now, another important thing to take into consideration is your interpretation of what is really going on with the forces between them. Here you have block A, the red one. Then you also have block B, the blue one. And then you also have block C, the orange one. And now you tell yourself, what is going on with the forces between them? Well, really, if you consider what a normal force is, it is basically the interaction between two surfaces when objects are pushing against each other. So you could think that this normal force that we have here, that's just basically an interaction between blocks A and B. So if you name it the normal force 1, another way to consider it is that this is the force that block B is exerting on block A. Now that's upward, but according to Newton's third law, this is also the force that block A is exerting on block B exactly downward. On the other hand, there is an interaction between the surfaces between blocks B and C. And so if there is another normal force here, that normal force 2, that should be equal to the interaction exerted by block C on block B, which should be the same in magnitude as the interaction between block B exerted on block C. One of them is upward, one of them is downward. And finally, you know that there is a surface at the bottom, a table or floor of some kind, and then if you have an extra normal force here, that extra normal force Fn3 should be equal to the force exerted by the floor on block C. So that's this kind of interaction. So many times a greater understanding is obtained if you really think what is the interaction that is happening between objects. Because in this case, if you now come forward with your free body diagram and you tell yourself, well, probably the block that has the least amount of forces is the top one. So let's do a free body diagram of the top block. In that case, you have your traditional mg, but this is block A, so it's mag, the weight. And then you have normal force. Now we call this normal force Fn1, but in another language, this is F that B is doing on A. And so, according to your equilibrium equations, the sum of forces in Y is equal to 0, which means that the normal force minus mg is equal to 0, or in other words, your normal force Fn1 is equal to 45.08 newtons. And that's all well and good, but it's only 1/3 of the problem. Your next part is about block B, and block B is a little more complex, because in block B, at least this tells you that there are two forces being exerted. The force that A is exerted on B, and the force that C is exerted on B. And on top of that, you have gravity. So here is your block, and you have gravitational force, mass B times G, and because you have FBA upwards, then you have FAB downwards. Now you have FAB, and there is a second normal force, Fn2, but in language for the third law, this is the force that C exerts on A. Taking now your equations from equilibrium, you end up with the sum of forces in Y is equal to 0, or normal force 2 minus normal force 1 minus mass B times G is equal to 0, which ends up telling you that the normal force 2 is equal to 56.84 newtons. And so that's the interaction between the blue block and the orange block. Finally, if you want to consider the free body diagram for the bottom block, the orange one, you need to think that in a parallel situation, there are three forces acting. There is the old gravitational force, mcg, on object C. Then there is the normal force 2, because that is the force that block B is exerting on block C. So this is normal force 2, and finally there is an upward normal force Fn3, which is the force that the floor is exerted on block C. And so in your equations you have sum of forces in the y direction is equal to 0, normal force 3 minus normal force 2 minus mcg is equal to 0, and so your normal force ends up being 93.1 newtons. So how do we read this? Well, basically, notice something about these results. The normal force 1 is the smallest one, which probably means that normal force 1 is just holding up the red block, block A. Normal force 2 is larger, and that's probably because normal force 2 just has to hold up both block A and block B. In other words, normal force 2 is equal to the sum of the two weights. And finally, normal force 3, that's even larger, And that's because this normal force has to hold up all of the three blocks, the A, B, and C. So the important part here is that you have several interaction pairs, starting with this normal force 1 here and here, and continuing with this one, normal force 2 here and here. And of course, they have to be equal in magnitude and opposite in direction. So that's it for today, guys. I'll see you later.